look at one of my favorite topics, and what I think will be one of the unifying themes of the course is the idea of graph theory. So I just want to introduce you to this problem. It's one of the more famous problems in the history of mathematics. This is called the bridges of Königsberg problem. So Königsberg is in what is now Russia, and the problem basically is this: if you have these islands and you have these rivers, and they're connected by these bridges, which are marked in red, and what you want to do is you can start anywhere that you want to, and you can end anywhere that you want to, and you want to take a walk through Königsberg, and you want to cross each bridge exactly once. You can't retrace your steps and cross the bridge twice. You can't leave out any bridges. You only want to cross a bridge one time. And you can look at that for a while, and you can try different things, and you're not going to have much luck because it's actually impossible to do that. So that is, that's a problem in mathematicians trying to understand. What is it about that makes it it's impossible to take a walk like that where you can only cross each bridge exactly once? So for a problem like that, it's helpful to visualize it in a different way. We look at the islands or land masses as points, which are actually called vertices in this theory, and the bridges are segments, and they're actually called edges in graph theory. So if we visualize the problem that way, it actually helps us to understand why that particular problem is impossible. So graph theory is pretty fascinating. It has all kinds of different applications. One common application is airlines use it to figure out where they should locate their hub cities and how many hub cities they have, what's the most profitable way to arrange that. Another really common application of graph theory is looking at, maybe familiar with, the 6 degrees of Kevin Bacon. So I'm sure you all know how this game works. You take any movie star, you can connect him or her to Kevin Bacon through a certain number of movies. For example, Ronald Reagan is considered to have a Bacon number of 2 because he was in the movie The Young Doctor with Eddie Albert, and then Eddie Albert was in the movie called The Victor with Kevin Bacon. So it's separated by 2 degrees. So this graph theory can be used to understand a problem like this. So lots of people think, well, they picked Kevin Bacon because he's been in a movie with everybody, so this just seems like he's a logical person to use for this game. But through graph theory, we can actually understand that Kevin Bacon is really not the best person to play the 6 degrees of Kevin Bacon game with, but actually, this guy is the most connected actor in Hollywood. That's Dennis Hopper, in case you are not familiar with that. But, so we should really be playing the Dennis Hopper game. So these days, graph theory is becoming more important than ever. And the reason for that is that today, in the year 2012, we have the biggest graph ever in the history of mankind. And can anyone guess what that graph is? Facebook, exactly. Facebook, you can consider those points on the graph to be people. And Facebook has actually 845 million of those points, 845 million users of Facebook. You can consider the connections between those points to be friendships or different kinds of relationships between those people. So understanding these relationships is a very important problem, and it's a problem that there is a huge amount of money to be made. That's in fact why Facebook is valued to be around $75 to $100 billion. If we can understand those connections between people and who are the people that are influential, then advertisers are very interested in that information. So that's an area of growth in mathematics that can be very important. And so there's a lot of room for exploration. So we're going to spend a lot of time looking at that in this class.